Hi there and welcome to Code Framer. So in the last 3 videos we understood about different solid design principles. So first we discussed about the single responsibility principle, and then we understood about the open close principle, and in the last video we understood about the Liskov substitution principle. So in this video we are going to continue to learn about the next design principle, which is the interface segregation principle. So having said that, let us begin. So first of all, let us recall what is interface segregation principle. So a simple definition or simple explanation of this particular principle is that it is always good to create multiple smaller interfaces rather than creating one giant big general purpose interface. And why is it so? Because whenever you provide a general purpose interface to client, then there is a high possibility that the client may not use many different features that are available in that particular general purpose interface, because the client may want to use only specific part of the interface and not the entire interface. So in such cases, it is always good to create multiple smaller interfaces so that you can provide only the requested interface to the client, or you can say only the usable interface to the client. So now, having understood this, let us see an example to understand that what really happens when you basically breach the interface segregation principle. Now, as part of the example, just imagine that there are multiple clients out there who basically want you to create an interface using which they will be able to implement certain features into the machines that they have. Now, say for example, different clients have different machines with them. Now, what are these machines first of all? So these machines can basically perform printing operations. So they can take any document and they can print that document, and then they can scan those documents, they can photocopy those documents, or they can fax those documents. So there are different functionalities that they can implement into these machines that they have. So as part of this example, just imagine that you have different clients and they have different machines, and they want to basically have an interface using which they can implement certain features into their respective machines. So you have to create that particular interface. Now, as a developer, what you decide is that, okay, so I have different clients and they have different machines. So what I'll do is, instead of just creating different interfaces for these clients, I'll create a general purpose interface and I will just provide that single interface to all these clients. So based on their own respective requirements, they can use this interface, right? So this is what you decide. So in order to write this interface, what you can do is you can write a class and you can name it, say for example, machine, and inside that class you can basically create the methods using which they can implement the features, right? So as I said that the machines have different features. So the first method that you can create is def printing. So the machines can basically perform printing on documents. So you can write a method for printing and you can take document as the input argument, and you can raise not implemented error here. And then you can create the second method, which is the, say for example, scan method, and you can again take the document as the input here. Again, you can raise the not implemented error. And then you have fax. So again, you can take the document as the input and you can simply raise not implemented error. And then finally you can also have a method for photocopy, and here also you can take document as the argument or the input parameter, and then you can raise the not implemented error. So this is the general purpose interface that you have created for all the clients, right? So now let us say for example, one of your client is having an advanced machine, right? And in that advanced machine, the client can basically implement all the features that are available in this particular general purpose interface, right? So in order to write a class for that particular machine, you can write class, and let us name this particular machine as advanced machine, right? So you can write advanced machine, and then you can inherit from the machine interface. And inside this particular class, you can basically implement all these methods, right? So there is no problem at all, because this machine can basically support all these features. So you can just write some meaningful implementation in all these methods, and it should be absolutely fine, because this machine can support all these functionality. So it is not at all a problem. So you have basically created a perfect interface for, say for example, client 1, which has this advanced machine. But your client 2 or other clients that you have, they don't have an advanced machine which can basically support all these features. So what they want is, say for example, an interface for an old printer. Now say for example, client 2 has an old printer which does not have functionalities like scanning or fax, and say for example, it has only the functionality of printing and photocopy. So in that case, you can write a class and say for example we name it old machine, and again here you are pulling the general purpose interface or inheriting the general purpose interface, so you can write machine. But inside this, if you just implement all the methods that are available in the general purpose machine, then it won't make any sense, right? And moreover, the client does not even need these interfaces that you have provided to this particular client, because for this client only these two interfaces are enough, which is printing and also the photocopy. But when it comes to fax and scan, this particular client does not need these two interfaces. But when the client uses this particular machine interface and basically inherits this particular machine interface, he will get access to these methods as well. And that's where the problem really lies, because this particular client does not need the access to this interface, but he has the access to this interface. Now, one of the way of solving is simply to, give certain kind of a message to this client. So which means that you can basically write raise not implemented error, and you can pass an message to the client that this method is not usable. So you can write this raise not implemented error to the client so that he knows that these methods are not usable for you, or these methods are not meant for you. But still it doesn't really help, because end of the day your client has the access to these interfaces, right? Which means that he may be tempted to use these methods, and after encountering a particular issue or a problem, then he may come to you and say that because you provided the access to these methods, we used it and now we are in a trouble. So this is the kind of risk that you may have if you write a general purpose interface. So you may end up providing certain interfaces or certain part of the interfaces to a client which the client does not even require. And to be precise, they must not have the access to those interfaces, because it is not meant for the functionalities that the client has basically requested. So you should not provide them the functionalities that are not going to be used by them, because if by mistake or by intention they use those interfaces or the methods which they are not supposed to use, and eventually they end up being in some kind of a trouble or problems in their system, then the first question that will be asked is that why this interface was provided to this client which is not going to be used by the client on the first place. So in order to avoid this kind of a situation, what can we do? Now that is the question. So now I hope you understand that why interface segregation principle is so important, because providing an interface, a general purpose interface to a client who does not require certain part of the interface or who must not have certain functionalities of a particular interface should not be given that interface. As simple as that. So which means that if you are providing a particular interface to a client, then the entire interface must be usable by the client. So if there are any part in the interface which is not usable by the client, then you must not provide that particular interface to the client. As simple as that. And that is exactly why interface segregation principle is so important when it comes to general design principles. So now, having understood the importance of following the interface segregation principle, now let us see that how we can create multiple interfaces and provide only the specific part of the interface to the client, so that the entire interface that we are providing to a client is 100% usable by the client. And that is something very important that we must always ensure, that the interface that we are providing to the client must be 100% usable by the client. So in order to solve this, what we can do is, since we have created a general purpose interface here where we have just implemented all the functionalities as methods inside this particular interface, we can create separate interfaces for all these functionalities. So what we can do is, we can create a separate class and we can create abstract classes here. So in order to create the abstract classes, as I have told in the last videos, we need to import the ABC module, or we can say from ABC import ABC, and also we will import abstract method. So we can write class printing. So which means that for printing functionality, we can create a separate class, and here we can write ABC in order to create this class as abstract class, and inside that we can create an abstract method, and we can write def printing, and we can take document as the input parameter, and we can simply write pass. Similarly, we can create one more class for scanning. So we can write class scanning, and then we can write ABC in order to make this class an abstract class, and inside that we can write abstract method, and then we can create a method for, or an abstract method for scanning, which will also take document as an input parameter, and then we can write pass. Similarly, we can create the abstract classes for fax and also photocopy. So we can write here fax, and here we can write photocopy, and then inside fax we can write fax as the method, and inside photocopy we can write photocopy as the method name. So these are the four interfaces interface that we can basically provide to the client so that they can implement the features based on their requirements into their machines. So now, say for example, a particular client only requires printing as the functionality that he would want to implement in his machine. So in that case, we can write a class now to our old machine and we can simply inherit the printing interface. So now you can only implement the printing method inside this particular class, and you can basically implement some meaningful implementation here, which means that now the old machine is not having any functionality inside the interface which is not usable by this old machine, which means that you have provided an interface to the client where the client has no access to any irrelevant features inside a particular interface. So the interface that you have provided to this client is 100% usable by the client. And now say for example, another client wants you to give an interface using which basically he can implement printing and also scanning functionality in his machine. So in that case, what you can do is you can create a class. Now say for example, the name of this particular machine is multi-function machine. So in this multi-function machine, since the client has requested you to provide methods to implement printing and scanning functionality, what you can do is you can provide these two interfaces to the client, which means you can provide printing as one interface and then also scanning as one interface. So which means that now this particular client has access to this printing method and also the scanning method. So using these two methods, now this particular client can basically implement the required features into his machine. So the client can have some kind of a meaningful implementation here. So I hope that now you are able to understand that how basically splitting a large general purpose interface into smaller interfaces can basically help you to provide the specific requested interface to different clients, and how helpful this is. Because as you can see here, that even if a particular client wants you to provide an interface which can perform all these functionalities, and he wants to basically write meaningful implementations for all these functionalities into his machine, then in that case again you can write class and say for example, this is that advanced machine that we had earlier, and now inside this advanced machine you can basically inherit all these interfaces. So you can import printing interface, you can import the scanning interface, fax interface, and finally you can also import the photocopy interface. Since you have imported all these interfaces, you now have the access of all these methods that are defined inside these interfaces, which means that the client can have meaningful implementations of all these methods into his machines. So this is the benefit of interface segregation principle. So I hope that this is clear. Now there is one more thing that I want to explain here, is that you can also create combinations of these functionalities or these interfaces, and then you can provide that specific interface to the client. Now what I'm trying to say is, say for example, there are many clients out there who want you to just provide interface to implement two features, which is printing and scanning. So you can expect that in today's machine, most of the machines, printing and scanning is one of the most common features, right? So say for example, there are many clients who are just requesting you to provide an interface to implement these two features. Now in order to do that, what you can do is you can write a class and say for example, you can give it a name as multi-function device, and here you can basically inherit the two interfaces that you have, which is printing and scanning. So these are the two interfaces that you have basically inherited to this particular interface that you are creating for all those clients. So as part of this interface, what you do is you create abstract methods, and inside that you again implement the printing method and also the scanning method. So you can write abstract method, and inside that you can write scanning, and then you can simply write pass. So this is a new interface that you have created, which you can provide to all those clients who are specifically asking you to provide interface for printing and scanning. So this is like a combination. So you are basically combining two interfaces and creating one single interface, and this interface you can provide to all those clients who are asking these two specific features, right? So using this particular interface, now say for example, there is a client who wants to use this particular interface, then simply he can create a class and say for example, the name of his machine is multifunction machine, right? And for this multifunction machine, he wants to basically use multifunction device interface. So you can simply pull the multifunction device interface. So one thing I want to tell you is that whenever I'm using the word pull, it is not actually pulling, it is inheriting a particular class or a base class into your derived class. Okay, so I'm just using it for a simple explanation of what I'm doing, but always remember that whenever you are writing class inside brackets, it is always inheriting from that class. So it's a base class, and the class on which you are inheriting that particular class is the derived class. So now you have inherited the multifunction device interface into this particular class, and now here you you can implement the scanning and the printing functionality. So which means that the client who have requested you to provide a specific interface for printing and scanning can now use this particular interface, a single interface, and they can basically implement those features. So this is how you can also group the interfaces together and provide one interface to specific client. So like that, you can have better segregation of interfaces based on the client requirements. But always remember that the interface that you're providing to the client must always be 100% usable by the client. That is the kind of implementation that you should go for when you are creating interfaces for the client. So this is what interface segregation principle means. So I hope that with this example, it is absolutely clear to you how we can follow the interface segregation principles in order to create our interfaces for different clients, and also what really happens when you breach this particular design principle. So I hope that this video was helpful. So if you have any doubts or queries related to this particular design principle or any other design principle that I have explained before, do not forget to mention those queries in the comment section. I will definitely respond to you. And also if you have any feedback or suggestions, then do post them in the comment section below. So in the next video, we will understand about the last and the final design principle, which is the dependency inversion principle. So I hope you enjoyed this video and also you were able to get a lot of value out of this video. So if you like this video, then hit that like button, share it with other code lovers, and also subscribe to CodeFramer for more videos in the future. Thank you and see you next time.